Today we're going to talk about differential calculus derivatives of exponential and logarithmic function. To differentiate the log or exponential function, or to differentiate len, you need to follow specific rules. If you have f of x, for example, equals e power x, then the first derivative should be e power x. But if you have, for example, g of x equals e power 3x squared, the first derivative, which is g dash of x, becomes, you need to differentiate the exponent, which is 6x, and then times the function itself, which is e power 3x squared. This is the first scenario. The second part related to the len x. Then to differentiate len x, which is the second part, if you have f of x equals len x, then the first derivative becomes 1 over x. But what if you have like L of x equals len 4x cubed? Then L dash of x becomes the derivative of this part, which is 12x squared, over the equation itself without the len, which is 4x cubed. And after that, you're going to simplify. 12 divided by 4 becomes 3, and x squared over x cubed becomes x. This is L dash of x. Now we have the first example to deal with. He said in the first example, he said what? He said differentiate each of the following functions. Then about the first one, which is a, to solve the first question, we need to determine f dash of x. Then the derivative of 5 becomes 0, and the derivative of negative 2e power x becomes negative 2e power x. This is the first function. What about question b? We have g of x equals len x over 2. Then g dash of x becomes half by len x. But this is, this is g of x. This is like just only adjustment on the equation itself. Then to find the first derivative, g dash of x becomes half, and len x becomes 1 over x, then half by 1 over x, which is 1 over 2x. The third question, which is c, we have y. Then you need to differentiate with respect to x, because it's the variable here. Then it becomes dy over dx equals, the derivative of 6 becomes 0. And here we have negative len e power 3 over x. Then here we can deal with a specific rule, like we can adjust this equation, becomes 6 minus len, then minus len e power 3 minus len x. Do you remember this rule? Which is to differentiate it, like if you have, for example, log a over b equals to log a minus log b. And if you have log a b, it becomes log a plus log b. Okay? Okay. After that, you're going to differentiate. Then you're going to cancel len with e, because len consists of log e base e of e. Right? Len equivalent to log base e only. Then you're going to cancel this part, and it becomes 3. Then here you have 6 minus 3 plus len x. And 6 minus 3 becomes 3 plus len x. Then you're going to differentiate len x. Len x equals 1 over x. That's it. I think it's clear till now. What about the second example? If you need to find the equation of the line tangent, here you need to find the equation of the line tangent. And we say before, if you differentiate the quadratic, for example, and you said find the tangent or the gradient for the tangent line while x equals 1, then I gives you like specific point here. And this is the gradient for the tangent. When you substitute f dash, instead of becomes f dash of x, it becomes f dash of 1, then the result should be the gradient for the tangent. And after that, you're gonna put the gradient of the tangent and y equals mx plus c. And instead of m, you're gonna put the result such as 2, for example. Then it becomes y equals 2x plus c. To find the y-intercept, which is c, you're gonna substitute instead of x by 1, and instead of y by its value on the curve. Okay? Then here he said find the equation of the line tangent to each function at the specified value of x. Then express the equation exactly. He said express the equation exactly. Then I'll solve the first question and the second question. Be with me, please. First of all, you're gonna differentiate it. Then dy, here in the first example, dy over dx equals e power x. Then after that, e power x. If you need to find the gradient, then you're gonna substitute instead of x by 1. Then e power 1 becomes e. And this is the gradient. This is the slope of tangent line. If you need to find the point, which is x and y, you're going to substitute in the first equation. Then to find y, it becomes e power 1 plus 1. Using your own calculator, you're going to find the result then. E power 1 equals e, and e plus 1, I think, equals 3.71, right?
Do I do it on the calculator?
Yes, do it, please. E plus 1 becomes 3.72, approximately 3.72, to the nearest three significant figure. Then the point was 1 and 3.72. This is the point. And the gradient should be e, and e equivalent to 2.72. Then this is the tangent line, or the equation of the line tangent. Then y equals mx plus c. And instead of m, I'll put 2.72. Then y equals 2.72 x plus c. Now you need to determine the value of c. We have the point, the critical point here, which is the point of intersection between the curve and the line of the tangent. Then, instead of x, I'll put 1, and instead of y, I'll put 3.72. It becomes 3.72 equals 2.72 plus c. Then, for sure, c will becomes 1, because you're gonna send it to the left side.
How did we get 3.72?
Okay, because here in the equation, instead of x, I substituted by 1, and after that e power 1 becomes e plus 1 becomes 3.72 using your own calculator. Then while x equals 1, y should equals 3.72. Okay, then here we found the y-intercept, which is c equals 1 here. And c equals 1, then the final result, which is the tangent equation, should be like that. y equals, where's the gradient? 2.72, or e. Then I can put ex plus 1, or I can put y equals 2.72 x plus 1. Both are the same. Okay, is it clear?
Yes.
Okay, within 2 or 3 minutes, you need to solve the second question. Give a try. And within 2 or 3 minutes, you need to solve it. Okay, I'll give you 3 minutes.
Can I use calculator?
Yes, sure.
Okay, I saw.
Yeah, tell me about the equation of the tangent line.
1 over 4x plus 1.39.
Plus what?
1.39.
1.39. Check this part, because the first part was completely right. Here, first of all, you need to what? You need to differentiate the equation. It becomes y dash equals 1 over x. Then substituting instead of x by 4, it becomes 1 over 4. This is the gradient, completely right. But if you need to determine the value of y, while x equals 4, then you're going to substitute in the original equation, which is y equals ln 4. It becomes approximately, I think it's 1.39, right? Yes, 1.39, it's completely right. You can write it 1.39, you can write it by 1.4. Both are the same. Okay, this is 1.39. Then, while x equals 4, y should be 1.39. And after that, sorry, let me pause this stopwatch. And after that, okay. Then after that, after finding the gradient, you're going to substitute in the y-intercept equation for like y equals 1 over 4x plus what? Plus c. Then you need to find the y-intercept. Then you're going to substitute using this point. And instead of x, you're going to put 4. And instead of y, you're going to put 1.39. Then 1.39 equals 4 by 4 plus c, right? This is the value of x and this is the value of y. And after that, 4 by 4 becomes 1, right? Then this is 1 equals 1.39 plus c. Then the value of c should becomes 1.39 minus 1, which is 0.39. This is the value of c, right? Then the final result should be y equals 4x plus 0.39. I think now it's clear.
Yes.
Okay, thank you. Let's move further. The chain rule. What is the chain rule? This is a critical rule. Sometimes you're going to find like composite functions. Composite function consists of two functions, such as these functions. And then you need to differentiate with the chain rule. Here you're going to differentiate without the chain rule. Directly, y dash becomes negative sine x, y dash negative sine x. And here, I think it's 6x plus 5, and then 1 over x. And then this part, third, x power negative 2. And after that, you're going to drop the power, and so on. Got the idea? But for these questions, for these functions, you need to use the chain rule. How can we use it? I'll solve some of them using the chain rule. Then, the chain rule, if you're gonna use the first one to apply the chain rule on the first equation, y equals cosine 2x. I'm sorry. Then y equals cosine 2x. Give me a second. Yes, cosine 2x. You're gonna let or substitute that u equals 2x. Then instead of this 2x, you're gonna put it like that, like y equals cosine u. And instead of finding, and focus with me, instead of finding dy over dx becomes du dy over du times du over dx. How can we do that? I'll tell you. Y equals cosine u, then you're going to differentiate with respect to u. Then cosine u becomes negative sine u, right? And u, you're going to differentiate it with respect to x. Then du over dx becomes, this is not like the suitable part. This is the value of u. Then du over dx becomes 2, right? Here you have two solutions, like du over dx and dy over du equals negative sine u. And here you have the value of u, which is 2x. Then you need to put them together. How can we do that? Using this rule, which is the Shen rule. dy over dx equals dy over du times du over dx. To make it clear to you, I'll do it again, but let me put everything together first of all. dy over dx equals what? Equals dy over du. Where is dy over du? This part. Negative sine u, right? By du over dx. Where is du over dx? 2, right? Okay, here we have another variable, which is u. And u equivalent to what? To 2x, right?
Yes.
Yes. Then the final result should be negative 2, which is this 2, sine, and instead of u, I'll put 2x. This is the final result.
Okay.
You need to solve it again, right?
Yes.
Okay, once again. Here we have y equals cosine 2x. And you need to differentiate it. You're going to use the Shen rule. Shen rule means dy over dx equals dy over du by du over dx. Then you need to convert it. Y equals cosine u, while u equivalent to 2x. Then notice that u equals 2x. You're going to differentiate this equation and this equation. Then from this equation, you're going to differentiate with respect to u. This is the variable. Then it becomes dy over du equals cosine u becomes negative sine u. And what about this part? Du over dx becomes, you're going to differentiate with respect to x becomes 2. After that, putting them together, instead of u, you'll put the value of u, which is 2x. Then you're going to substitute in our original equation, our original rule. Then it becomes, as a solution, dy over dx equals the first part dy over du, this part, negative sine, and instead of u, I'll put the value of u, which is 2x. This is the value of u, which is 2x, by du over dx, which is 2. Then it becomes negative 2 sine 2x. I think it's more clear right now.
Yes.
Okay. What about the second question? Let me do the second question. Which is here, we're gonna deal with what? We're gonna deal with y equals second root of 3x squared plus 5x. We talked before, we can differentiate it directly, like u dash equals 1 over 2 times the root itself, which is 3x squared plus 5x, times you need to differentiate this part, right? It becomes what? 6x plus 5, right? Then the final result should be 6x plus 5 over 2 times the root itself, which is 3x squared plus 5x. This is a method, and we can use the chain rule to use it, to apply the concept on this equation. Let's use it. Then
where did we get 1 over 2?
1 over 2.
Like 2.
Again?
The part you just wiped, it was 1 over 2.
Yes.
And then root 3x.
This is a rule. This is a rule when you deal with the roots. Like if you have the second degree for the root, this is a rule. We talked about it before, right? Then let's take this equation. This is the final result here to compare our solution. U in this scenario equals what's inside the root, which is 3x squared plus 5x. This is the u. And y becomes root u. Till now, is it clear? Then y equals u power half, and then you're gonna find dy over du with respect to u. It becomes half, and then u power negative half, which is half by u under the root, right? And to find du with respect to x, it becomes 6x plus 5, right? Okay, now we have two parts. The first part, which is dy over du, which is 1 over 2 by root u, and the second part, du over dx equals 6x plus 5. The time for merging them together. Then dy over dx becomes this part. Okay, this part becomes 1 over 2 root u, and we know that u equals what? 3x squared plus 5x, right? Okay, 3x squared. Okay, 3x squared plus 5x times du over dx, which is 6x plus 5. Now we found the same result, 6x plus 5 over 2 root 3x squared plus 5x. Same result or not?
Yes.
Same result, right? Okay, now you need to solve the third one and the fourth one, please. It's your order to solve the third and the fourth one, please. And I'll give you 5 minutes to solve both of them. Okay, 5 minutes means left will be 4 minutes and 30 seconds. Okay, Ala, is it clear till now?
I solved the first one, but the second one I'm unsure of.
Okay. Think about it.
Okay, I solved it.
Okay, tell me about the final results.
Number 3 would be negative 3 over 1 minus 3x.
Yes.
And number 4 would be 6x plus 1 over 3x squared plus x.
Think again about the fourth question.
I'm not sure
What to do? Okay, think, and focus with me, please. Okay. Thank you for your effort about the third one. I was completely right. About the fourth one, you need to focus about this question. Okay. Let me deal with it. Here we have y equals this equation. Then y equals 1 over u. While u equals 3x squared plus x. Then first step to do is to find dy over du. And it becomes here y equals u power negative 1. Then you're going to drop the negative. After that, it becomes subtracting 1. It becomes u power negative 2. You're going to put it in the denominator. Becomes u squared. Clear? Then about du over dx becomes 6x plus 1. Then we know that dy over dx equals dy over du by du over dx equals dy over du, the first part, which is negative 1 over u squared. And u in this scenario represented by 3x squared plus x. Then 3x squared plus x squared times the second part, which is du over dx, which is 6x plus 1. And 6x plus 1 in the numerator equals negative 6x plus 1 over 3x squared plus x over 2. Is it clear?
Yes.
Okay, thank you. Okay. I think this question is really an amazing question. He said the polynomial function y equals 16x power 4 minus 8x squared plus 1 equals 4x squared minus 1 all squared is the composite of y equals u squared and y equals u squared and u equals 4x squared minus 1. And he said here, use the chain rule to find dy over dx. Okay, then u equals 4x squared minus 1 and y equals u squared. Then y equals, or dy over du equals 2u. And du over dx equals 8x. Now, time to merge both of them together becomes dy over dx equals dy over du by du over dx. And instead of dy over du, we're gonna put 2u, then 2 times the value of u, which is 4x squared minus 1. And instead of du over dx, I'll put 8x. And by 8x. And becomes 2 by 4 becomes 8x squared minus 2. Then 8x squared minus 2 by 8x. Clear? Then 8 by 8 becomes 64. And x by x squared becomes x cubed. Negative 2 by 8x becomes negative 16x. Clear?
Yes.
Okay, if you differentiate it directly, this part, which is dy over dx directly equals 64 x cubed minus 16x. That's it. Right? Both are the same. Okay, I'd like to thank you.